In this recording, we are working on solving a polynomial equation, and the way we do that is by factoring. Now, always pointing out, when you see the word solve in your directions, or maybe the directions were way above the question, right? And it's not right above the exact example, but it's applying to an entire section. You need to recognize that when you have an equal sign, pay attention. When you have an equal sign, it is going to be something you'll solve. You won't just stop at factoring. So one of the first steps is we want to get everything onto one side of the equal sign so that you only have a 0 or nothing on the other side of the equal sign. We also, while we're doing this, try to make our leading coefficient or leading term positive, so the one with the biggest exponent, and we want everything in standard form. All like terms are combined. Please don't try to be a rock star or a hero and just do it in your head. Why? Because 95% of you who think you can do it in your head cannot. And when you see this minus, you end up making it negative. You make a disaster. You pick things up and you put them down. You need to do algebra. You need to do the inverse operation to move things from one side of the equal sign to another, or whatever it is, depending on the problem. So from here, the new line of the equation will read x to the 4 plus 12x to the second minus 64 is now equal to 0. We like that. We like it equal to 0. Now that it's equal to 0, and the directions are even telling us to solve by factoring, but sometimes we solve by graphing, sometimes we solve in a couple other methods, but now we know if it says to solve by factoring, it should be factorable. We have a power here on our trinomial that is double the power of this, and here we have no variable. This is going to be a quadratic type. It's obviously not a quadratic. This is a quartic trinomial, but it is a quadratic style, and we can we can factor this using our AC method with grouping. What does that mean? Well, that means we're going to multiply the A and the C. A is 1 right over there. So AC is negative 64. And we're going to find a pair of numbers that multiplies to give us negative 64 and then adds to give us positive 12. 1 and 64, 2 and 32, 3 does not go in, 4 and 16, 5 no, 6 no, 7 no, 8 and 8. Bottom of the list, B equals 12. Which pair? Positive 4 and positive 16 and negative 4. Got a little overly eager. Another reason I end up marking off points often is because people are putting the wrong signs for the two middle terms, where they're splitting that middle term. And a lot of it, I think, comes down to instinctively you want that middle term to be positive. I think you just default to that. But the reality is sometimes it's negative, and you just have to make sure you do that. So let's split this up. I don't write the 1, but x to the 4, then minus 4. This time you put x squared. So whatever that has on it, that is what the two middle terms get, right? Because we're taking that middle term and splitting it up into parts. It has to have the same variable and exponent combo, right? Minus 64 is 0. And this has to work. If it doesn't work, then you messed up somewhere else along the way, or you're messing up here. Numbers are designed to work. Now, GCF here, x squared. GCF here, 16. Write the plus. Stop trying to be sloppy and lazy. You're not getting the right answer. You're making mistakes. When it's a minus and you don't write anything, when it's a plus and you don't write anything, you guys fill in along the way, and sometimes you just repeat the sign that was in the parenthesis before it, but sometimes that's not right. Just do the math, okay? This is called doing math. Now, x squared that we're dividing by gets multiplied out front, plus 16 that we're dividing by gets multiplied in front. Reduce it using our little pretzel method. What do we have? X squared minus 4. X squared minus 4. Twins. So we're going to take that x squared minus 4, pull that all the way out front. X squared plus 16 is what will be left inside? So again, x squared minus 4, that got factored out front. X squared plus 16 is remaining inside. That's how this looks. You do not lose the equals 0 along the way. Keep it there, right? You can't just magically start dealing with an expression. Just stop being lazy. Write things down. Now, that's a difference of squares. So we have x plus 2 and we have x minus 2. This is not. This is a sum of squares. We can leave it as is. We will talk about it more later. Set each of these equal to 0. X plus 2 equals 0. So x equals negative 2. X minus 2, a little squish, sorry, equals 0. So x equals positive 2, right? So that got equal to 0 here. Got our answer right there. And then x minus 2 equal to 0. Solve for x. Now this we would solve by taking square roots. There's ways that we could play with this, and like I said, I'll kind of show you a little variety in future lessons. But subtract over 16, negative 16, take the square root ourselves. When we take a square root of both sides, ourselves in a problem, you need the plus minus in front of your square root, and it's a plus minus the square root of negative 16. Now, if that were a positive 16, positive negative 4, beautiful, love it, done, great. But we have a negative 16. Some of you, depending where you are in your curriculum, you might just stop and say, no real solution. If you are a little further in the curriculum, then you would take it a little further where not only do you know there's no real solution, but you would also include what those non-real or imaginary solutions are. So the square root of 16, well, that would normally be positive or negative 4. And since they're not real, because no real number times itself is negative, that makes them imaginary. So we put the imaginary unit I right there next to it, which really represents the square root of negative 1. So here we have two answers, x equals positive 4i and negative 4i. If you just write, if you know this is not something you're being assessed on, imaginary numbers, you're on a different trajectory at the moment, then you could just write no real solution for this part. But this is also acceptable, or better even. And then the other two answers are real, x equals negative 2 and x equals 2. Sorry, it's so squishy. The biggest power in the problem over here was 4, so we got 4 answers really all together. Sometimes in the past, you may have just gotten the negative 2 and 2 and known at most you could have 4. But now we know the other two were just imaginary. I hope that this was clear. I hope you understood, and I hope you got this right on your own. Hope you're feeling good about factoring, solving, knowing to get it equal to 0, and to see the next example. Hopefully that box pops up on the screen soon, and good luck with the rest of them.